Right, in this edition of Applied Animal Feeding, we are going to start looking at tools that we can use to decide what feeds we're going to be utilizing in a ration. And this is what I call looking at the feed costs per unit of nutrient. So evaluating our feeds for the reason we're buying them. When we consider feeds for rations, we go back to those IFN categories. Categories 1 through 3 are all the roughages. Category 4 is the energy feeds. Category 5 is the protein supplements. 6, 7, and 8 are, I believe it's minerals, vitamins. I sometimes mix up minerals and vitamins, and additives. Okay, so if I'm building a ration and I want to add calories, I know that I need to look for an energy feed. But say I know that I need to increase the protein of a ration, then I'm going to be looking at protein supplements. And so that's our first decision, is what kind of a feed are we needing to enhance this ration? And then we can look at the feed cost per unit of nutrient as a tool in our tool belt. It is not the final answer. There may be other factors, such as the quality of the feed, if there's mold or any issues in the feed, that would affect us using it in a ration. But the reason we do this and take a look at these feed costs is we know that feed is generally one of the highest variable costs, and over 60% of all costs for producers of their production costs. And so a small impact, positive impact on reducing feed costs can really affect the profitability or improve the margin for an operation. However, over the last several years, we see it in all of our daily lives. We have escalating costs, right? Everything is getting more expensive every day. Fuel, groceries, everything. The same is happening with feed costs. Same dynamics are in play. And so the more that we can reduce those feed costs and find better alternatives that can get the job done, the better chance at a more profitable outcome that producer will have. So when considering feeds, we've got to think about their general characteristics. Generally, roughages are going to be put into a diet to add dry matter. The energy feeds are going to be put in to add calories of some kind. Protein supplements are used to add protein or amino acids to a ration, etc. And so we'll kind of work with these three factors right now, but we could source feeds based on the price per unit of calcium, vitamin B12, or whatever the case may be. And so if we think about this, when we're buying, again, no judgment of Selena's art skills, okay? We're buying a truckload, that's my truck, there's the pipes, okay, of feed, whatever that feed is, okay? We're buying, say, a load of hay. There we go. Probably should be more of a flatbed than a livestock trailer, but you're with me. We know that part of that feed is water. And we don't really care what's in the water element. We want the dry matter basis, because we want to know what that cost is for this part that we're buying. Okay. Then say if we wanted to look at protein, we would want to know the protein within that dry matter. So that's how we're going to set up this math to be able to answer the question, what is our feed cost per unit of nutrient? Okay, there are 3 steps to doing this. First you identify kind of what the general category is. Step 1 is going to be determine the pounds. How many pounds do we have in a given weight? And let me be more specific about that. Pounds of dry matter. Okay, so we may be working with a ton, which is 2,000 pounds. We may be working with a counterweight, which is 100 pounds. We may be even working with a bushel weight. Corn is sometimes sold and marketed on the bushel, which is 56 pounds. You may have to look up some bushel weights. So we need, and these would all be on an as-fed basis. So to determine the pounds of dry matter in a given weight, we would take that given weight times the percent dry matter. That's going to give us pounds of dry matter. That's the first step. Is like in our load up here, we're accounting for the water, getting rid of it. The second part, step 2, is how many pounds, determine how many pounds, I should say pounds or mcals of nutrient are in the dry matter. So now that we've isolated our dry matter, we need to be able to isolate the exact nutrient, like how much protein is in that dry matter. Okay? And so that's going to be the pounds of dry matter times the nutrient concentration. And that's going to be the decimal form of it. So if it's 15% protein, we're going to convert that to the decimal form, which would be 0.15. And that's what we would use in this equation. Step 3 is simply divide the cost, which would be the numerator, by the nutrient amount from step 2. So it's 3 steps. Determine how many pounds of dry matter in a given weight, determining how many pounds or megacals of that nutrient are in the dry matter, and then divide the cost by that nutrient amount. And that's going to give us the cost per unit of nutrient. And this allows us to be able to rank feeds. And again, it's meant to be just a tool in the toolbox, not the all-knowing. So let's work through an example. Let's take a look at a feed, Distiller's dried grains. And we're going to look specifically at the corn version of this. Okay? So now the first thing we need to know is we want to know the cost per unit of dry matter, protein, and a measure of energy. So let's go mcals of net energy for maintenance. So we need to look up these values. So I will put a version of this in where you can link to it. This is version 1 of my searchable feed table. It is not clean. There are probably some errors in here, so use with caution. I can also recommend the Noble Feed Library, but we need to kind of, there's a couple different ways to do that. So let's take a look. I'm going to start my search, and in my spreadsheet, it's sometimes easier to just write part of a word and see what you get. Okay, so it separates out, and here is the Distiller's Grain corn dried. That's the one we're going to be using. So it is 91% dry matter. If I scroll over to protein, it is 29% crude protein. And if I cruise over to NEM, it is 100 mcals of NEM per hundredweight. Okay, so we've got to kind of just keep that in mind. But that gets us our data. And if we were to look up the feed cost for this, which I did recently, this is costing about $240 per ton in California. So now let's take a look at how we would use those 3 steps to figure out the cost per unit of nutrient. Okay, so we have all of our data right here. So first things first is step 1. We flip back, is determine the pounds of dry matter in a given weight. So the given weight that we're working with is whatever the price is in. So this is in a ton. So we want to know in 2,000 pounds or 1 ton, how much dry matter is in there. And so we multiply that times the decimal form of the dry matter percentage. And when I say decimal form, that is simply taking the 91%, dividing it by 100 to get 0.91. That's how I got this number right here. Those of us that have been around a little bit longer and a little more seasoned in our years, we just simply look at a percentage and move the decimal 2 places to the left. But whatever works for you and how you've learned percentages. So we're going to do that first. So 2,000 times 0.91 tells us that there is 1,820 pounds of dry matter in that ton of distillers dried grains. And if we go back to our dry matter as fed video, it should be a smaller number because we're mathematically removing the water, so we should be reducing the weight. Now, the second step was to figure out in that 1,820 pounds of dry matter, how many pounds of crude protein do we have? So that is 29%. So we're going to use the decimal form. So we're going to take 1820 times 0.29. And so we have 527.8 pounds of crude protein. Sorry, I bounce between hashtag means pound sign for me, so I've used that for pounds for years, or writing it out. Along with that, we also want to know how many megacalories are in that. So 1,820 pounds of dry matter times, okay, now this one's in megacals per hundredweight. We need to convert it to a per pound basis because we've got to have pounds since our major weight is in pounds. So again, this is simply going to be divided by 100. 100 divided by 100 equals 1. Or you could do the same thing of moving the decimal 2 places to the left. So we're going to have 1,820 mcals of NEM. Okay, so we now know how many pounds of dry matter, how many pounds of protein, and how many pounds or megacalories we have of net energy. The third step is to figure out that cost per unit of nutrient. Let me bounce back to our steps. Determine how many pounds, we've done that. Now we're going to divide the cost by the nutrient concentration. Okay, so for dry matter, the cost was $240 per ton as is. In that ton of as is feed, we have 1,820 pounds of feed, of dry matter. So what you're going to wind up with is cost per pound of dry matter. Cost per pound of dry matter. So if we take that 240 divided by 1820, that tells us that we have 0.132. Now on cost, I will round to 3 decimals because you can get several feeds that are 0.13. And then that third decimal may help distinguish which one truly is a possible better value. Next up, we'll do crude protein. So that same cost, and we know that in that dry matter and in that 2,000 pounds, we have 527.8 pounds of crude protein. So if we plug it in again, 240 divided by 527.8, we learn that, put a dollar sign there, that we have 0.455 cents per pound of, crude. Let me clean that up. I've become such a big believer in whiteout. Per pound of crude protein. So now if we had another protein source, we could compare this. And the last one was net energy for maintenance. So same process, $240 divided by the quantity, which was 820 mcals. So now on this one, instead of getting cost per pound, we're getting cost per mcal. So this is going to be cost per mcal of net energy for maintenance. And actually it should be that same number, but we're going to double check. And that is 0.132. Okay, so now we have some data points that we could compare this maybe to corn or some other, like if we needed calories, or in this case, to me, distiller's grains is a protein source, and I would want to compare it to other protein sources to see if I'd want to include it in a ration or not. But that's it. Those are the 3 steps to determining cost per unit of nutrient. And you could do this for cost per unit of calcium, phosphorus, or anything else, fat, fiber, whatever you wanted to make a comparison on going into a ration. And so understanding, it's kind of like when we go grocery shopping and you're looking at the cost per ounce of canned goods or something like that. Same process. Which one is the cheapest per unit? Now, is this the only thing that I would utilize to formulate a ration and decide what is in it? Absolutely not. But it is a tool in my toolbox to help me decide, hey, maybe I want to put distiller's dried grains in this ration to help reduce my protein costs. Hope that helps. And again, I will put that searchable database and maybe a few problem sets up for you to take a look at. Thank you.